Hi, good morning. For those of you in Nigeria and West Africa, um, welcome to High Score Online Tutorials. Today we have a question from JAMB, past question. JAMB is an entrance examination conducted for universities in Nigeria. Now, today we have a question in equilibrium of forces. It says that the diagram shows a uniform wood of weight 200 Newton and length 50 meters, pivoted at one end, suspended by a cord at the other end at an angle of 30 degrees to the wood. What is the tension in the cord if the wood is horizontal? Now, for this wood to be horizontal, it means the whole system is at equilibrium. That means the moment clockwise is equal to moment anti-clockwise. But before then, discover that this tension in the cord is not upward, neither upward nor downward, it's actually at an angle. So we have to resolve it to know the amount of force that is tending to push this wood upwards. And that angle and that tension, that force is the tension in the cord sine 30. For those who may not know how we got the sine 30, let's quickly do that. If you have a force going up like this, tension and horizontal angle of 30, the force tending to go push it up is, let it be Ty. So we can have a sine 30 is equals to opposite Ty by hypotenuse T. So that our Ty becomes equals to T sine 30. So in that case, this system can be reproduced as 200 Newton T sine 30. Yeah. Now, the weight of the wood must act exactly at the center of gravity of the wood. Center of gravity of the wood will be located at the midpoint between the first end to the other end, because to say that the wood is uniform. That means here it becomes automatically 25, half of 50, 25. So 25 plus 25 will give us the 50, being the length of the wood. Now, this force here, if allowed to act alone, we tend to drag this wood at a clockwise direction. Look at it. This force tends to make a clockwise turning, clockwise moment. While this one, if allowed to act alone, we tend to turn the wood anti-clockwise. In that case, sum of clockwise moment is equals to sum of anti-clockwise moment. And the moment is the force times perpendicular distance from the force to the point of pivot. Clockwise moment is seen in 200 Newton force. So that 200 Newton times the force, 200 Newton times distance from here to here, from here to this place is 25, times 25 meters is equals to anti-clockwise is T sine 30 Newton times distance from this force to the point of action is 25 plus 25, that is times 50 meters. so that this is equal to sine 30 is half or 0.5. So T times 0.5 times 50 Newton meter, or you can put the unit later when we are done, times 50. That should give us that 25 T. Therefore, 25 T is equals to 200 times 25. Dividing both sides by 25. 25 cancel 25 and 5, so that our T becomes 200 Newton. So the tension on this string is 200 Newton. Thanks for watching. Goodbye.